The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
If a buffer is 0.21 molar NH3 ammonia plus 0.33 molar ammonium, or NH4Cl, it's going to be ammonium, what is the pH? And they're giving us the pKb value. Now, two things that we want to note here. Firstly, it's already telling us that it's a buffer solution. If it's already telling us it's a buffer solution, we can go ahead and we can use the Henderson-Hasselbalch equation to find the pH. Furthermore, if we look here, we're being given pKb. So from the pKb, we'll calculate the pKa, and then we have everything that we need for the Henderson-Hasselbalch equation. So let's begin there. Well, we know from our previous lecture that pKa plus pKb is going to equal 14, right? And because of that, we can just go ahead and find pKa, which is just going to be 14 minus pKb, which is actually going to be equal to 9.25. Now we can go ahead and call upon the Henderson-Hasselbalch equation, right? Where we said pH equals pKa plus log of our ratio here of base concentration and our acid concentration. And once we go ahead and we fill in the numbers, that's going to be 9.25 plus, and what is our base here? It's ammonia, which is 0.21. That's being given to us, right? Over our acid concentration, which is just going to be 0.33. And once you go ahead and you equate this, you'll have a value of 9.05 as your pH. Okay, great. Now, there are a few things that we want to note here. Firstly, if we notice, our pH value is 9.05 and it's within 1 pH unit of our pKa. And because of that, we know that this is a good buffer solution, right? Secondly, if we wanted a solution with a pKa with a pH of 7, would this be a good would this be a good buffer solution? No, it wouldn't, because remember we said what you want is you want the pKa to be within 1 pH unit of the desired pH. In case you didn't get it earlier, that's what I was trying to tell you. It has to be within one pH unit of the desired pH. Okay, great. Now, what if we wanted a pH solution of let's say 9.3? What would be the mole ratio here for our ammonia and our ammonium then, right? Well, let me show you how to calculate that. Okay, great. What we can actually do is we can just actually reverse or reconfigure our Henderson-Hasselbalch equation to find out what it is exactly that we need. And we'll start here with our Henderson-Hasselbalch equation. So we'll just take the base over our acid. All right. All we're doing is we're just rewriting the Henderson-Hasselbalch equation, right, over here. So you should be familiar with this portion here. And this is going to equal 9.0 minus 9.3, right? And this will equal, oh, we actually had, it was 9.05. What was our, yeah, this was actually 9.05. That would make our answer then negative 0.2. Well, let me actually just write the entire thing out here. This is actually going to give us anti-log. Let me actually just go ahead and first write the base in. So our ammonia, right, over our ammonium Perfect. And that is going to give us our antilog, right, of negative 0.25, which we can actually just rewrite as 10 to the negative 0.25, which is actually equal to 0.56. Wonderful. This part right here, you can actually just rewrite it as over 1, right? And then that's telling us that for every 0.56 moles of ammonia, you're going to need 1 mole of ammonium. And that's how you can basically, you tweak until you get exactly what you're looking for. All right, great.